Good day to all of you. Today we shall discuss on Model Question Paper 1 with effect from 2023-24 CBCS scheme 3rd semester BE degree examination of the subject Digital Design and Computer Organization with subject code BCS302. In that we shall number 4a explain different modeling styles used to write the code in Verilog with an example. So it carries 5 marks. HDL means hardware description language. So in hardware description language Verilog, the module is the basic building block for modeling hardware with Verilog HDL. The module means it's a program here. So between reserved words module and end module, we write Verilog program. So that is the building block for modeling hardware means whatever digital circuit we want, that we can implement in the software form. Okay, not as hardware. Hardware means we'll have to bring the components, do connection, that is what, but here in software it is. Okay, the logic of a module can be described in any one of the following modeling styles. So in HDL Verilog, 3 modeling styles means 3 ways of writing Verilog program to implement any digital circuit. The first one, gate level modeling. This is also called as structural modeling. Uses instantiations of predefined and user defined primitive gates. Means in Verilog already some built-in functions will be there. For example, AND, OR, NOR, NAND, NOT. So using these reserved words we can create AND gate, OR gate. Okay. So like how we prepare a class, then instantiating that class means creating an object of the class. We write a program. Here whatever built-in functions, they are called as system primitives or system primitive gates. Using that any logic gate we can implement in Verilog here. So if they are built in, user also can define his own logic circuits. They are called as user defined primitives. So they can be used in any of the other Verilog programs as to create required circuit. Okay. So that is what is gate level modeling. In gate level modeling, predefined and user defined primitive gates are used. Gate level modeling describes a circuit by specifying its gates and how they are connected with each other. So for this kind of Verilog programming, we need to know the circuit diagram properly, which all gates are there and how they are connected. Okay. The second modeling is data flow modeling. It uses continuous assignment statements with the keyword assign. So in data flow modeling, we need not know the circuit diagram. We should know logical equation that represents that circuit diagram. Okay. Data flow modeling is used mostly for describing the Boolean equations of combinational logic. So to implement these Boolean equations, assign keyword is used. Third modeling is behavioral modeling using procedural assignment statements with the keyword always. So if any Verilog module or say Verilog program, if always keyword is there, then that program belongs to behavioral modeling. So behavioral modeling, that is used to describe combinational and sequential circuits at a higher level of abstraction. So out of 3, the first 2 are used for combinational, third one also can be used for combinational, but for sequential strictly we can use behavioral modeling, right? Gate level modeling includes 12 basic gates as predefined primitives. These are also called as system primitives. Gates are declared with the lowercase keywords A and D, comma, likewise NAND, OR, NOR, XOR, XNOR, NOT and buff. A single input can drive multiple output lines distinguished by their identifiers. Data flow modeling of combinational logic uses a number of operators that act on binary operators to produce a binary result. Verilog HDL provides about 30 different operators. Behavioral descriptions use the keyword always followed by an optional event control expression, and a list of procedural assignment statements. Okay. So this figure shows the list of the operators that are used in data flow modeling. So in gate level modeling or structural modeling, we have to use the system primitives, which are called as predefined primitives. They are to be used to implement the logic circuit. Their single input, if it is required at many places for the circuit, then by using proper identifiers that can be used. Okay. Now we shall take up an example, that is creating AND gate in Verilog. So in three models. First one, structural model. Here the program in all starts from module and end module. Okay, in all the three models. So in structural model, we shall see here AND system primitive is used to create a AND gate called G1. Its inputs are specified as X and Y, and output Z, it should always be specified in the first place next to list of inputs. So AND is the system primitive or predefined primitive. So in this program, one AND gate is created whose name is G1 and which is taking X and Y as inputs and giving Z as output. This is the end of program. So it started from reserved word module. Then name of the program is ANDSTR in bracket. So in this list, which are the inputs, which are the outputs, in any order we can write. But when we use system primitives, strictly first output literal only must be written. Inside, which are the inputs, which are the outputs, they are explicitly declared. So this is one processing statement, that is one AND gate is created. So end of the program. So this is a structural model kind of Verilog programming. Next, in data flow model, between module and end module the program is written. So AND DF is the name of program. Inputs, outputs in any order they can be listed. Here declaration, which are inputs and outputs, that is shown here or written here. Then assign is the keyword that is used in data flow model. Here logic equation has to be implemented, not circuit. If equation we know, that is more than enough. Using operators the equation is written. Here Z equal to X ANDed with Y. So that is what is written here. Assign Z equal to X. This is logically AND operator, ampersand, that is the operator, with Y, bracket complete, semicolon. So by writing like this, using assign keyword in data flow model, one AND gate is created. Next, in behavioral model, again module, end module, and BH is the name, set of inputs and outputs in bracket, then semicolon, declaration which are inputs and outputs is done here. Here for output always we should take as register. REG is the reserved word. Z is the output here, that is has to be declared as register. Then the keyword used is in behavioral model always. If any program always is there, then it is behavioral kind of Verilog model. If assign is there, that belongs to data flow model kind of Verilog program. If A and D reserved words are there, system primitives are there, that is structural model kind of Verilog program. Now here always, so at a set of inputs that has to be specified, then processing statement. Whatever logic equation was there, that will be written here. Assign keyword is not required, but with always this processing statement will be written. Next, end of the program. That is one example for structural model, data flow model and behavioral model. In them, how Verilog module is written for implementation of a digital circuit. That is simplest, one AND gate is taken here. So next, if we take another simplest circuit, that is Y equal to AB plus CD. So A ANDed with B, that is logically ORed with C ANDed with D. So y is this. So in structural model, data flow model, behavioral model, that program is written to implement y equal to a and b logically OR with c and d. So module, end module, in that the name of the program structural. So instead of writing in brackets list here directly which is input, which is output, that also can be specified. For interconnection between the parts of the circuit, wire is taken, that is temp1, another wire temp2. First one AND gate is created, its name is G1. So it is taking AB inputs and giving on temp1 output. So this AB is coming on temp1 wire. Next that is assigned to E. Okay. Here E is taken as in out. Means that E wire acts as input and output also. For A ANDed with B, it is acting as output wire. Okay, now it is output wire. Similarly, wire temp2, what is taken there? One AND gate is created whose name is G2. For that CD inputs are given. Output is made available at temp2. So CD output is made at wire temp2. That is assigned to F. So F is also made as in out. So next one more wire is taken, temp3. So OR gate is created, that is G3. So for that E and F. So AB output was available on E, CD output was available on F. They were output wires. Now here they are forming inputs to OR gate G3. So OR gate output is available on wire temp3, that is assigned to Y output because we want the output on Y. This is how Y equal to A ANDed with B logically OR with C ANDed with D is implemented in structural model. But if you observe in data flow model, what is difference? Logical equations are used. A ANDed with B is given to E. F is equal to C ANDed with T. So A ANDed with B is available on E. C ANDed with D is available on F. Then both are logically ORed, that is assigned to Y. Okay. So that is what is done here. So this is regarding data flow model. Next, in behavioral model, always keyword is used. Between begin and end processing statement will be written here. Y equal to within bracket A ANDed with B logically ORed with C ANDed with D. So in single line the equation is written here with operators. Here also it could be written that way only. Okay. But here this was representing this diagrammatically. Otherwise this single statement with assigned word we could write here. Okay. So this is all regarding the example for 3 types of modeling in HDL Verilog. I hope you understood. Thank you.